Welcome to the first video in a series of tutorials created by SolidWorks specifically for students participating in the Formula SAE program. In this video, I will cover the process of modeling a frame. I've already opened a completed frame. We're going to be going over the steps necessary to complete this final product. Before we begin sketching out the frame, we should actually consider where is the origin located in reference to the rest of the frame. In this case, I've decided to locate the origin at the intersection of the ground, the car center line, and the front axle center line. To make these planes, I've actually just renamed the front, top, and right planes to their respective names in order to locate the origin at this spot. This will be beneficial later so we can reference other things in the model to these planes. Now let's go back to the first step in this process, entering the suspension geometry. The suspension geometry will dictate a lot of the frame model, so it's important we enter it first so we have something to go off of. I've entered all the hard points for the A-arms into a single 3D sketch. These points dictate the design for the rest of the car, and they don't change, so I've decided to enter each one manually into the parameters box and then use a fixed relation to keep it fixed in space. I've also added an additional sketch that offsets the inboard suspension points. This will allow us to use these new offset points to directly define frame tubes. In addition, you might want to add things like planes defining control arms and the rear and front axle. Now that we have our suspension geometry input, we can start sketching out a skeleton for the frame. I've already sketched out the front and rear suspension box. Here, I've just used a couple of in-plane sketches in the front, 2 in-plane sketches in the rear, and then a 3D sketch to create the triangulation. I'm going to zoom in and show you exactly what I'm talking about in the rear. Here's the top in-plane sketch, here's the bottom in-plane sketch, and here's the 3D sketch showing the triangulation between the tubes. Now we can hide the suspension geometry so we can focus completely on the frame tubes. The steps so far should have been fairly straightforward if you're familiar with 3D sketching and sketching with planes. If you're not, I recommend going to the tutorials section of SolidWorks and looking at the 3D sketching and 3D sketching with planes tutorials. The next part of the frame I chose to outline was the roll hoops. I did this with 2 in-plane sketches. After this, I modeled the seatbelt, engine compartment, and driver compartment. These were all done with a combination of in-plane sketches and with 3D sketches for the triangulations. Finally, I completed the front structure of the frame. Now we have a nearly complete outline of the frame that has a sketched line for every frame tube. The next step is to assign structural members to each sketch line. If you're still using the default command manager, you may not have the weldments toolbar, so you should first go add it by right-clicking. Under the weldments tab, select structural member. Here's where we'll define our structural members and pick the sizes. Unfortunately, SolidWorks does not contain all the sizes we need for a Formula SAE frame. We're going to have to add some on our own. To create your own custom tube profiles, first open up a new part. Create a sketch on the front plane of the tube cross-section. For this example, I'm going to create a 1-inch tube with 0.95 wall thickness. Once you've completed the sketch, select it and go to File, Save As, and down here is Save As Type. Make sure to select the library feature part. Now we need to save it with the rest of the weldment profiles. For me, that's located in my Program Files directory. It probably will be for most of you too. Go to the SolidWorks folder, Data, and Weldment Profiles. Under here you already see what we had before, ANSI, inch, and ISO. I added a new folder called FSAE. This will appear as one of the categories in the drop-down menus for structural members. I've also added round and square categories. And here I've already saved one as 1 inch by 0.95 inch. Once we save that part to the proper location, we can go back to our original frame. Now, if I go up here like I did before and click structural members, there'll be a new category under Standard, Formula SAE. I can select Square or Round Type, and then whatever I save that file name as will appear as the size right here. Assigning a tube is as simple as just selecting the sketch line. You are able to select multiple sketch lines in order to create one tube. Here, I've created a single structural member for the entire main roll hoop. The process of assigning the tubes is pretty straightforward, so I'm going to go ahead and skip to the point where I have every tube assigned in the frame. At this point, it's starting to look like a frame, but there's still a few things we need to touch up. First off, we need to do some trims on these tubes in order for them to appear proper in the model. For example, you can see here, we have these tubes intersecting correctly, but then they protrude through the other tubes. To solve this problem, use the trim extend command. First select the bodies that you want to trim, and then let's select the boundary bodies to use for trimming. You may have to use the trim and extend command a lot in order to get your model right. As you can see here, for this model, when it's complete, I had to use trim and extend a fair amount in order to get every tube right. After completing all the trims, we now have a final basic frame. This won't be complete yet because you might like to add things like suspension tabs, gussets, and engine mounts, but this will give us a good initial weight for the frame and give us a jumping off point for the rest of our full car model. In a later video, we'll also be able to use this same frame model to perform FEA analysis and calculate a torsional rigidity for the frame. That's it for today's video. If you have any questions, comments, or suggestions for future tutorials, email them to sfaulkner@solidworks.com.